Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with linear regression modeling, and that too part 2. In the part 1 we have discussed about the simple regression modeling, and that too bivariate engineering econometrics, where we must have two variables, one is dependent variable, one is independent variable, and then the objective is to predict dependent variable with independent variable. And we have discussed how to estimate, how to obtain the estimated results, and the types of test to validate the empirical results and the regression model, and that to the line of the best fit to predict the dependent variable with respect to independent variables. In fact, we have gone through specification test, goodness of fit test, out of sample prediction test to predict the dependent variable with respect to independent variable, and that too with a good fit model. And the other part is the diagnostic test, which we have not covered, and after the multiple regression modeling we can touch upon that particular component. And in this particular lecture we like to solve some of the engineering problems where the situation will be more than two variables, that is a dependent variable with many independent variables. So here the rule is very similar, that to predict the dependent variable with respect to independent variables. In the part 1 we try to predict the dependent variable with respect to single variable, which is very simple, very easy to process and easy to predict the kind of engineering requirement. But in this case we have means we have this scenario where we have to predict the dependent variable, but instead of one independent variable we have multiple independent variables, and that is how the complexity will start. That means when you add one after another independent variable, the level of complexity will start increasing, because when we add one after another independent variable, one of the complexity will be obvious that there may be some kind of linear relationship among the independent variables that we need to check and to sort out the particular solutions before we go for predicting the y with respect to all the independent variables. So let us first see how is the multiple regression case, and then we will go through the reliability reliability part of this estimated models, where we will find all such problems will be there, and these will be included in the diagnostic kind of test, and we like to know how this diagnostic test can be used and can be applied, and to clean the estimated models before you do the predictions and the kind of forecastings. So usually the regression the multiple regression modeling will be like this, and here we have a dependent variable that is called as a y, and series of independent variables starting with x1, x2, x3 and xk, and then by default there is a requirement of independent means error terms. The involvement of error term in the models is essential, which we have already justified in the part 1. Whether it is a bivariate case or trivariate case or multiple case or multivariate case. So by default error term will be the mandatory component to do the processing for the prediction of y with respect to independent variable. And here the structure will be like this. So in implicit format, y equal to function of x1, x2, x3 and so on up to xk, and then there will be error terms. So the idea is that we like to check how these independent variables can influence the dependent variable. So the path diagram will be like this. So y is the dependent variables which can be connected with the several independent variables. So starting with x1, x2, x3, and then it will with x k. So, every times the impact will be unidirectional, since it is a multiple regressions. In the case of multivariate regression modeling, the impact may be bidirectional, but in this case the impact will be unidirectional. Every times we like to check how is the influence of x 1 on y, x 2 on y, x 3 on y, and likewise you can continue, and then x k on y, and that means every times we like to check individual impact, means individual impact of a particular independent variable on dependent variable. But while connecting more number of independent variables to y, that to independently means individually, then by default you must be and means you must be sure that all these independent variables are technically independent. So, that means if you look into this path diagram, so there may be some relationship among these independent variables like x 1 x 2 x 1 x 3, then x 1 x k, then x 2 x 3 x 2 x k, then x 3 x k. So, these are all possible correlation or association in the setup, since it is a more in a kind of multivariate scenario where one dependent variable with many independent variables. So, first of all that means technically first requirement is that all these independent variables should be technically independent, but in reality it is very difficult to obtain. So, our job is how to bring a kind of estimated model which is free from all these obstacles. If not, then we have to minimize it the level based, through which we can actually predict the dependent variable with these independent variables without any a kind of significant problems or a significant issue. So, so first of all, so we should ensure that all these independence variables are independent and they are all theoretically or logically must have influence on dependent variables. So, without any kind of knowledge or the kind of hint, a particular independent variable should not be involved in the estimation process. Otherwise, it will give you some kind of biased results, or sometimes it may be called as spurious regression. So, one means typically if you compare a strictly mathematical regression modeling than the engineering econometric modeling. So, one of the fundamental requirement is that you must have theoretical evidence or logical evidence before you start the process, because it is the concept of called as applied econometrics. It is not completely mathematical econometrics where you can connect x 1 with y, x 2 with y without any kind of theoretical evidence, because it is a mathematically well established technique. So, even if you do not know the nature of that particular variables, you can actually do the modeling. But since we are actually interested to solve some of the engineering problems, that means technically we are using regression modeling, and that too it is a kind of application towards the engineering problem. Means the whole objective is to work out the engineering problems through the help of engineering econometrics. So, we must have actually complete knowledge or complete evidence how these variables are connected each other before you start the processing, before you start the do the predictions and the kind of forecasting. So, as usual the general framework of multiple regression is like this, and this is implicit format and this is what the explicit format, and again you can write the problem like this: y equal to beta 0 plus summations beta I x I equal to 1 to n plus epsilon, that is the error terms. And if you actually make it separate, then it will start with y equal to beta 0, beta 1 x 1, beta 2 x 2, beta 3 x 3 up to beta k x k, and since it is a k, so this should be I equal to k. So, as a result, when I equal to 1, then it becomes beta 1 x 1, then when I equal to 2, it will be beta 2 x 2, and so on and continue where I equal to k, then the last term will be beta k x k. So ultimately this is the model. So that means this model can be transferred to this way, or if you generalize this model, this can be come into this way. So depending upon the kind of requirement, either you can put this way or you can put this way. Okay. So here the objective is to estimate these parameters, that is beta 0, beta 1, beta 2, beta 3 up to beta k. So as usual, like we discussed in the part 1, so beta 0 is the intercept, which represents that when x all x are 0, still y has some kind of weight. For instance, the previous problem which we have discussed is called as costing determinants of costing, that to airline industry, and where one of the independent variable is the number of passengers. So that means when number of passengers will start increasing or decreasing, the cost of the airline will start increasing and decreasing. So that means number of passengers will affect the costing of the airline industry. So when there is a change happening in the case of number of passengers, so the costing will also change accordingly. So usually theoretical hint is that when passengers are high, cost may decline; when passenger will be low, cost may more. So because it cannot actually, when passenger will be low, it may not possible to minimize the fixed cost, but when passengers are high, we can actually very much optimize the fixed cost. That's why, so increasing passengers will have a significant negative impact on costing. So that means increasing passengers will reduce the cost factor, and decrease the passenger will increase the cost factors. So that is how the case we have discussed. So then if you put x equal to 0, where number of passengers, and the cost factor will not actually 0, because it will take care by the intercept factor. So that means technically in the part 1 we have discussed the model up to this point, okay, plus of course plus error term. So here this one is the airline passengers, and this is the total airline cost. So now when the passengers are 0, then still the airline cost is there, because some fixed costs are always there, whether passengers will be in the system or not, because passenger is the ultimate customers for this particular industry. When customer will be in or customer will be out, then the cost variation will start affecting. But still, even if there is passengers in the system, still there will be the cost, because the initial setup involves large amount of the cost. So as a result, since initial investment is the large one, so to optimize the process and to go for cost effectiveness, so you have to increase the passenger size, so that it will reduce the cost factor as per the particular industry requirement. So now what is happening in this case, we add one after another variables to justify that same airline cost can be affected by the passengers, the infrastructural availability, manpower availability, or something like that, investment or advertising. So many factors which can affect the airline cost. So once you identify the particular independent variable, then you can add into the system, then it becomes simple to multiple one. So now mathematically this is what the model, without knowing the means, without connecting to any engineering problem. So let us first know the mathematical concept behind this multiple regression modeling, and then we will connect to a particular problems and to check how these these problems can be processed, and then what type of outcome will be obtained, and how to do the predictions and how to do the forecasting, and that too with the check of reliability and something like that. So here these coefficients, beta 0 is the intercept, as usual discussed in the case of bivariate regression modeling, and then beta 1 is the slope coefficient for x 1 variables, beta 2 is the slope coefficient for x 2 independent variables. Similarly, beta k is the slope coefficient for the x k independent variables, and k is the number of independent variables, and epsilon is the error terms. So, that means technically we have couple of independent variables through which we can actually predict the dependent variables. So, as usual, so the predicted model will be y hat equal to beta 0 hat, beta 1 hat x 1, beta 2 hat x 2, beta 3 hat x 3 plus it will continue, then the final term will be beta k hat x k, and then by default error term will be removed. So, that means the original y involves intercept and all these independent variables, and then the predicted and the error term, then the estimated model will be only intercept and the estimated parameters that to connect with all these independent variables. So, by default, so the difference between y and y cap, that is y estimated, will give you the error weightage like the previous case which we have discussed in the part 1, that to bivariate regression modeling or simple regression modeling. So, that means technically whether the system involves 2 variables or 3 variables or 4 variables. So, the stepping to obtain the empirical model will be more or less same. So, you must be very careful how you have to deal with this situation, and you add one after another variables, but systematically it will be derived. Of course, the complexity part is that the relationship among the independent variables, otherwise the process is more or less same, whether it is a bivariate structure or trivariate structure and multivariate structure. So, let us see how is this kind of environment, and then how we can obtain the particular process. So, let us as usual I have mentioned. So, y cap is the estimated models, and by default error term will be removed in the process. So, as usual we have to apply the ordinary least square mechanism initially until unless we have something wrong, and then the process of OLS is to minimize the error terms, and the way we will minimize the error terms, by default we will obtain the estimated parameters, and these estimated parameters will help to predict y with respect to all these independent variables. So, by default, so beta 1 b 1 is the estimated value of b 1 is the estimated value of beta 1, and then b 2 is the estimated value of beta 2. Similarly, b 3 is the estimated value of beta 3 hat, and b k is the estimated value of beta k hat. So, and b 0 is the estimated value of beta 0. So, likewise we will means we have all these estimated parameters, and in comparison to first equations where all these parameters are unknown, now with the help of OLS and then with the help of with the availability of data, the way we will process all these estimated all these unknown parameters to be now known. And once you know all these estimated parameters, then it is easy to predict y with respect to all these independent variables. That is the usual procedure through which you can actually process the things, get the estimated model, and then go for the reliability check, and then go for the predictions and forecasting as per the particular engineering problems requirement. So, now let us see the first step is the structure of the multiple regression modeling, and the second step we have the estimated model of the multiple regression modeling and the kind of understanding between the variables and the parameters, and then the kind of involvement of error term. So, now in order to simplify the particular process, because when you talk about multiple regression, so we just generalize that it starts with the x 1 x 2 up to x k, but x k, when I write x k, then it is a kind of infinite sign, because we do not know what is exactly k. But for applications or when we like to solve a kind of an engineering problem, so make sure that all these variables are clearly identified. Until unless you close the loop or identify all the variables, you may not start the process. So, the moment you will start the process, so everything should be in a particular loop. So, the number of variables, the sample size, the kind of functional form, everything should be clear, either through some kind of homework and testing, checking. Then at the end of the day, your basket must be all kinds of informations with removal of all obstacles. Then you can easily proceed and do the processing and have the estimated model and go for solving the engineering problems as per the particular requirement. So now these are all very simple to convince and to understand them process, but ultimately how is the kind of setup. Since beta k x k is the kind of infinite signal, so in order to understand the reality and the kind of structure for the engineering problem predictions and the kind of forecasting. So let us bring a particular situation where y equal to only beta 0, beta 1 x 1 and plus beta 2 x 2. That question is called as or that particular structure is called as trivariate modeling. In the trivariate modeling, so that is also multiple case. So that means in the first instance you can have two different structure or the kind of modeling. So in the first case it is a simple bivariate, and this second case it is the trivariate and kind of multiple. So that means, so the minimum requirement of one independent variables and the more than one independent variable. It may be start with 2 independent, or it may be 20 independent, or it may be 30 independent. When the number of independent variable will start increasing, then the complexity will start increasing, because you have to address two different issues altogether when you are dealing with multiple regression modeling. The first requirement or first issue is you have to check the existence of linear relationship among the independent variables, and again you have to be very careful about the sample size. For two variable case, then the sample size may be small one, but when we add one after another variable, then the sample size should start increasing accordingly. Otherwise, keeping sample size remain constant, if you add one after another independent variable, then you may not go for means you may not in a position to test the model and to validate the model before you start predicting and forecasting. Because sometimes you may not obtain the parameters while processing with a particular data, because of the low sample size and large number of variables. In fact, in the first lecture of regression modeling, I have given you some kind of instruction, the particular requirement before you start or using the regression modeling for the solution of a particular engineering problem. What I remember, I mean what I have discussed earlier, that one of the fantastic requirement or typical requirement is your that is the equation or game between n and k, the sample size and the number of variables. So every time your sample size should be substantially greater than 2k, and that means n greater than 2k. Compared to previous problem, the airline cost determinations, where we have analyzed the problem with respect to two variables, the airline cost along with airline passengers, and where we have started the problem or investigated the problems, or we have connected the regression modeling with that airline cost determinations with sample size of 12 only, because in that problems your sample size n equal to 12 and k equal to 2. So 12 and 2, so there is no such significant issue. Of course, for econometric kind of principle or statistical kind of principle, so we have two rules of sampling. One is called as small sampling and another one is called as a large sampling. So the division between small sampling and large sampling depends upon the size of the sample 30 to 32. So when it is actually less than 30 or less than 32, so it is called as small samples, and more than 32 it's called as large samples. But the meaning of small sample, large samples, which can be very easy to understand, easy to pick up in the context of bivariate setup. But when we have more number of variables, then technical, for instance, instead of 2, if we 20, then the small sample, large samples with the particular typical link like 30, 32 will not actually convince you, or it actually not help you to solve the problem. So the simple understanding or simple structuring is that you must have enough sample size and that too you must be in a position to optimize significantly with the equation between n and k. So, that your degree of freedom should be substantially very high to validate the models as per the particular requirement. So, now these are all the kind of clarity and understanding before you start the processing, whether it is a bivariate or trivariate or kind of multiple. So, in order to justify the kind of things, so we can restrict the model with two independent variables. So, when your model is with two independent variables, that becomes called as multiple regression, but when we have actually only one independent variable, that is called as simple regression modeling. So, now here with two variables, two independent variables, it is called as also multiple regression mode, because one of the fantastic issue between bivariate and multiples, that means simple regression and multiple regression, is the number of independent variables involvement and their relationships. That is most important typical difference between these two different cases. So, now since the typical issue is the relationship between independent variable, so when there are two independent variables, that relationship can be there, but when more such independent variables, then the number of relationship among the independent variable will start increasing, and by default the complexity part will start adding in the process of investigation, in the process of estimation. As a result, so the issue will be very complicated, and until unless you solve these issues, you should not start the process, and you cannot use the particular regression model for the requirement of predictions or forecasting of a particular engineering problem. So, now we have so now the general models can be restricted to two independent variables. For that, so this is the first and requirement, okay, and then this is by using a particular sample, this is the estimated model with respect to independent variables. So, that means it is typically y x1 and x2. Okay, so obviously x1 has a influence on y, x2 has a influence y. So, this is hypothesis 1 and this is hypothesis 2, and this can be additional hypothesis which you can create, where H3, and the H3 indicates that there is no link between x1 and x2, but in reality there may be some link, but as per the requirement of multiple regression, that link should not be statistically significant. If that link is completely 0, then you are absolutely in perfect path, but situation is something different when you integrate something or solve a particular real life problem or any real engineering problem. So, you will find these variables are not really independent. So, they may have some kind of relationship, and you try to actually minimize that relationship, or sometimes when two variables are same and you are introducing in the system, then the problem the estimated model will have some kind of biasness. So, that means what is happening in reality, there may be high chance that x1 and x2 are same, but the way you will introduce in the system are different. For instance, let us take an examples in a kind of financial environment. So, we have a kind of component called as inflation, and while predicting the kind of airline cost or a real estate problem, means housing price, etc. So, inflation can be one of the factor. Of course, it is a macroeconomic variables, but still it has some kind of a link to the original problem, and in that instance what you will do, you can actually link the inflation factor and predict the housing price or airline cost or something like that. So, now what is happening to these particular problems or the kind of discussion is that you must have something like means understanding that your airline costing means determining airline costing or housing price should be actually clear with all these independent variables clarity. For instance, if you use inflations, and now how you have to actually measure the inflation. So, inflation rate is also still there, And sometimes what is happening, if inflation data is not available, because these models or this process are exclusively depends upon the data to get these parameters value, and when inflation data is not available, then you can use the proxy variables, that's called as intermediate variable, through which you can actually obtain the actual variable, that is inflation here. And for that there are two different variables which can be used frequently to get the inflation factor, that's called as consumer price index CPI and wholesale price index, that's called as a WPI. So now both are actually used independently to calculate the inflation, and that variables, that is the inflations, can be used as an independent variable to predict the airline cost, or to predict the housing price, or to predict the engineering productions, or something like that. So in that case, if you are not having clear cut understanding or something lack of knowledge, then there is a high chance that you may use CPI and WPI in the system, because CPI WPI actually has a different kind of understanding, different kind of information, but all will give you the hint about the inflation. So now instead of using inflations, if it is not available, then you may use CPI, either CPI or WPI. But if you simultaneously use CPI and WPI, and that too for naming x1 and x2, then there is a high chance that x1 and x2 will be highly correlated. So in the first instance, you can drop a particular variable, either CPI or WPI, and keep WPI and CPI as per the particular requirement, and then go ahead with the prediction. Then the problem by default will be solved. So that means technically this kind of scenario, so you first understand the reality, understand the problem, then you check whether these independence variables are something same or different. If theoretically they are different, you can keep, and then even if theoretically they independent, but with the help of some kind of structuring and the process of integration, these variables may have some kind of relationship, and then you try to layer down that kind of relationship by using some kind of mathematical structuring or data structuring or something like that. Then ultimately at the end of the day, you have a clean environment to do the things as per the particular engineering problems requirement. So this is what the trivariate case, and that to restrict the model with two independent variables, and then we will see how is the particular process. So this is the actual scenario, and this is what the estimated scenario. Here B1 is the estimated coefficient of beta 1, and B2 is the estimated coefficient of beta 2, that too for x1 and x2 impact respectively on y dependent variable y. So this is what called as estimated model. And if you actually plot this case in a kind of plotting case, that's the 3D, then this look will be like this, and how this y will be reflecting with x1 and x2. Ultimately the flow chart will be like this for a regression modeling. This is what visualization process. Ultimately the actual flow of model you can cite mathematically or with a kind of flow chart, but in reality it may be something different. We can start with the concept like this. That means this is what we need actually. You see here, so between x1 and x2 there is no relationship, but ultimately when you linking y with x1 and x2, there may be chance that x1 and x2 are actually linked. So this is not actually valid, but this is actually valid. So but what is the actually reality, whether you are in this track or this track? So you need to check and then proceed accordingly. Unfortunately, if you are here, then you should not proceed with the prediction and forecasting. So you try to bring this case to this case. If not like this, somehow little bit closer, and then you go ahead with the kind of prediction and forecasting. This is what the real understanding and real need you must have before you start processing the kind of things. Then ultimately, so this is what the kind of structure. So now like the part 1 where we have discussed the link between y and only x, For instance, if you restrict the generalized model to two variable case, then it becomes y equal to beta 0 plus beta 1 x 1, and then by using OLS, where we like to minimize the error sum square to obtain the parameters like beta 0 and beta 1 for predicting y with respect to x 1. So, we once we actually go through the optimization process by minimization of means that is to minimize the least error sum squares. So, we will have two different equations, that is with respect to beta 0 and beta 1, and with these two equations you can get the formula of beta 0 how to obtain from the data, and then beta 1. Similarly, in the case of trivariate, where we have a dependent variable within two independent variables. So, then when we process, that is the error terms which is equal to y minus y hat, where y hat is not actually beta 0 beta 1 x 1s, it becomes beta 0 beta 1 x 1 beta 2 x 2. So, that means there are two different components. So, ultimately, so beta 0 beta 1 and beta 2. So, we have a three different equations. So, now if you solve these three different equations, then you can get the formula of beta 0 beta 1 and beta 2, that is the estimated beta 0, estimated beta 1 and estimated beta 2. And then with the help of the data, if you do the processing twin manually, so you can easily obtain these unknown parameters, that to beta 0 beta 1 and beta 2. So, this is how the structural form of these equations. So, with the help of, so for instance, your spreadsheet or data will give you something like this. For instance, it will be like this: y equal to x 1 and x 2. So, you must have a data, you must have a data, you must have a data. So, now summation x 1. So, here you will get summation x 1, and summation x 2, here you will get summation x 2, then summation y, here you will get summation y. So, then again summation x 1 you can have here, but summation x 1 squares means, what will you do? You can create a particular component again x 1 squares, that is squaring all these items. Then you can also squaring x 2 squares, and then you can create x 1 and x 2. So, by multiplying these two, so you can have here some, you can have here some, you can have here some. So, that means you can get also summation x 1 square, summation x 1 and x 2, and summation x 2 square. Again, so you can create another kind of column by integrating y x 1s and y x 2 to fill this particular component. Then again you take this sum, take this sum. So, ultimately from the original data set y x 1 and x 2, so you can get summation x 1, summation x 2, summation y, summation x 1 square, summation x 2 square, summation x 1 x 2, summation x 1 y, summation x 2 y, and then finally you simplify these three equations. Since there are three parameters and three equations, you can easily get these values, and then it becomes means you will come to a kind of position to have the estimated model, to do the predictions and do the forecasting as per the particular engineering problems requirement. How to do this processing, and that with three variables we will discuss in the next lecture. With this we will stop here. Thank you very much. Have a nice day.